Hi everyone, and welcome to AI Inspire's first snapshot. Today we're going to be talking about linear regression, which is a type of machine learning algorithm. Linear regression is a great way to get started when you're learning about artificial intelligence, and today we're going to learn how it works by using biology as an example. Have you ever wanted to predict what temperature it takes for DNA to denature? I haven't, but I'm sure it would be useful to know in things like PCR, where a major step is denaturing the DNA. As it turns out, the temperature that DNA denatures at is directly correlated with the amount of guanine and cytosine in the DNA. This is also known as the GC content, and it's measured in percentages. So, in order to predict this, you'll first need to denature a bunch of DNA segments with different percentages of guanine and cytosine, and record how long it takes for each DNA segment to denature. You'll probably see results like this. So, you know that DNA with a GC content of 30% will denature at 90 degrees Celsius. But what about a 90% GC content? That point isn't on the graph, so you'll have to predict it. How? Using a line of best fit. You draw a line through the data that minimizes the error and allows you to make the most accurate predictions. What is error? Error is basically the distance from each of the points to the line. You want to make this total distance as small as possible. You can also think of it as the difference from the line's predicted y value, which would be like a point over here, and the actual y value, which is one of the measurements that you recorded. Here is the actual equation for error. I'm going to be writing the equation for mean squared error, which is basically an average of all the distances of the real points from the line of best fit. The 1 over n means you're taking the average. The summation notation means you're adding up the squared distances of the differences between the actual y value and your predicted y value. Why are you squaring it? To make all of the negative distances positive. So that's all that linear regression is, creating a line that best fits the data by minimizing the error. Here is the actual equation for linear regression. It's really similar to the slope-intercept form of a line, where each variable is multiplied by a weight, and a final bias is added on at the end. Your computer changes the W and B values as it learns from the data, until it gets the line closest to the data. You can have as many variables as you want. For example, what solution the DNA was stored in also has an effect on what temperature it denatures at. So you would add another WX term to your equation for that, and it would look like this. And that's all for today. I hope it got your synapses firing, and I'll see you next time.